Hello everyone, welcome back to our channel. Today we'll walk you through how to create a BLDC motor controller circuit using the input, output, and speed voltage control approach. Before we begin, let's first figure out how exactly the I/O plus SV approach works in BLDC motor control. The I/O plus SV approach is used to control the speed and direction of the BLDC motor. Input-output signals are used to enable/disable the motor, change its direction, and provide basic control functions. In this project, the rocker switch is used to control these signals. In a BLDC motor driver context, SV stands for speed voltage and refers to the dedicated input pin on the driver that allows you to adjust the motor's speed using an external potentiometer or analog signal. If you're using an external potentiometer to adjust the motor speed, the wiper of the potentiometer is usually connected to the SV terminal, while the other potentiometer ends are connected to power and ground. The potentiometer acts as a rheostat, providing variable resistance that corresponds to the wiper position. The variable resistance directly translates to a changing voltage signal sent to the BLDC driver via the SV pin, which in turn adjusts the motor's speed based on that voltage level. Therefore, by combining these two flexible control methods, the I/O plus SV control provides a comprehensive and efficient way to manage the operation of a BLDC motor in various applications. To begin, gather your essentials: a BLDC motor and its supporting driver, a potentiometer, a rocker switch, and a 24V DC power supply. These components will form the core of our motor control circuit. Now let's proceed with the wiring. Connect the power supply to the appropriate power input pins on the driver. Connect the motor phases to the designated motor output pins on the driver. Connect the Hall sensor signals to the dedicated Hall sensor inputs on the driver for accurate commutation. Connect one end of the potentiometer to the power supply positive, the other end to ground, and the wiper to the SV pin on the driver. Connect one side of the rocker switch to X1 on the driver and the other side to X2 with the ground wire to COM. Next, we need to make some settings change to our motor driver. Disable the RV function on the controller by turning the RV cross-screw head counterclockwise to fully off, and set SW1 and SW2 to the off position as per the instructions. Once all components are properly connected, you now have a functional BLDC motor controller circuit ready for operation. The rocker switch is used to control motor start or stop and direction change. When switched to position 2, connection is made between the COM and X1 pins, starting up the connected motor. We can confirm the connection by checking continuity between COM and X1 with a multimeter. The indicator light verifies the connection is made. On the other hand, switching the rocker to position 1 will connect the COM and X2 pins, thus changing the motor direction. Likewise, the continuity testing between these two pins confirms the connection. The potentiometer is used to adjust the motor speed. To operate the circuit, use the rocker switch to enable the motor by toggling it to position 2, and rotating the potentiometer adjusts the motor speed accordingly. Switching the rocker to O stops the motor. However, shifting it to position I changes the motor direction, while the potentiometer remains able to control the speed. That concludes our demonstration on controlling BLDC motor speed and direction based on the I/O plus SV approach.